Hi everyone, so I thought I'd just give this a go, this question. I think it's related to what some of the double mathematicians are working on at the moment, and it's nice to see a proof of these results, even though you do get a proof later on in the proof by induction chapter. But here's just another way of approaching it. It's a lovely little cute step question from the old days where they're basically getting you to prove that if you knew that the sum of r squared could be written in cubic form, then you can easily find the formula for the sum of r squared, which is nice, which is should be familiar. It's one of the standard results which you have to learn for the exam. I don't know, maybe they do give it in the formula book, I can't remember. But yeah, and then we do the same thing for the sum of r cubed. So I'm going to give it a go. I haven't worked through this already, so I might get stuck along the way. But yeah, let's have a look at it. It looks like quite good fun. Okay, so what are we saying here? Right, we're saying firstly that the sum from -1 down there, that probably gets you sort of scratching your chin and thinking, not from zero. But that's okay. We can go from -1 on these things. It works exactly the same way. Now we know that can be written of the form pn cubed plus qn squared. I'm a big fan of writing things down when they tell me them, and seeing if things sort of like happen in terms of how I'm thinking about it as I write it down. My first thought is, they're going to get me to set n equal to -1. In other words, I'm just going to plug -1 squared in there, and when n is -1 on this side, I'm going to end up with an equation in terms of p, q, and s. So I'm going to end up with p, q, r plus r, p plus q plus r plus s, or p minus p plus q minus r plus s, actually, in the case when r is -1, and that's going to equal 1, because -1 all squared is 1. That's what I'm thinking straight away, which is nice. I can see how they would produce four equations if I change those values, basically. And then I might be able to, if I know p, q, and r and s, I might be able to then do something crazy to adjust the -1 into a 0. And yeah, that's what I'm thinking anyway. So those are my initial thoughts. Let's give it a go. So n equals -1. Like I say, we're just plugging in -1, so we're not summing anything really, we're just plugging in one term, and that should equal, well, -1 cubed is -1, so that's going to be minus p, then it's going to be plus q, then it's going to be minus r, then it's going to be plus s. That's what I was just thinking about. So in other words, +1 equals, equals those letters. So let's write it like that. Okay, what do we get when n is 0? Well, this time we've got two terms on the left hand side. We'll have -1 all squared, which is 1, and then 0 squared, which is 0. And then you're going to have 0, 0, 0, 0, so you're going to get s equals 1. Okay, that's interesting. Straight away we've found s. That's nice. So I tell you what, I wouldn't normally have the luxury of doing this, but I'm going to do this like that, and just gradually, as I figure out things, that's going to happen. Okay, when n is 1, you've got three three calculations to do, if you like, and then add together. You've got -1 squared plus 0 squared plus 1 squared, so that's actually going to add up to 2 the left hand side now, and that's going to be equal to p plus q plus r plus s. But s, of course, is 1, so I'm going to put p plus q plus r plus 1. Let's simplify that to just 2 equals, but then again, take away the 1, 1 equals p plus q plus r. We could simplify that too, because that's going to have a 2 on the left hand side. Take away the 1, 1 equals p plus q plus r. Smashing, n equals 1, obviously same old, -1 squared plus 0 squared plus 1 squared plus 2 squared this time, so it's going to add up to a bit more. These are going to be, I've written down n equals 1. Why is that? Sometimes I do that when I'm talking. I've noticed I make more mistakes on the board when I talk. But yeah, plug in n is 2, and I'm going to get 8p plus 4q plus 2r plus 1, because s is 1. And so what have I got now? I've got 6 -1, 5 equals 8p plus 4q plus 2r. Yeah, lovely. So really, rather than solving, let me write this one out clearer. -p plus q minus r equals 0. So rather than solving a system of 4 equations and 4 unknowns, which was worrying me at the start, I've actually got to solve a system of 3 equations, 3 unknowns, because s was so obvious. Like, let me make that more obvious, 5. Okay, and then we're going to, I guess, if we added these two together, can you see you'd end up with 2q equals 1? And that's going to give me q equals a half. I'm just talking about this equation here and this one here. Let's call it a and b. Yeah, I suppose I should demonstrate good practice and make my working much clearer for the people marking. I do have a bad habit. I'm just like all my students. Okay, so a plus b, let's help the marker out here, equals 1 equals, the p's cancel, the r's cancel, but the q's double, so q equals a half. Lovely. So now we've got two equations and two unknowns. That's how we're always boiling it down. Here we could say minus p minus r equals a half. Yeah, that is equals minus a half. In other words, p plus q plus r. Sorry, p plus r. Sorry, my pronunciation and everything else. P plus r is going to equal positive a half. Cool. Okay, that's from a plus b. Now I guess we'll just chuck in a half into here, so we'll get 2 there. Take it away, we'll get 3 equals 8p plus 2r. Let me just check I'm doing everything correctly. Yeah, I think so. And I've got, obviously, from the previous, this minus a half equals p positive a half equals p plus r. Okay, let's double that. So 1 equals 2p plus 2r. And so in the end, what do we get here? We get 6p equals 2. So p equals obviously a third. Just checking everything. Sorry if I paused. If you thought I was struggling to simplify 2 over 6, it wasn't that. I was just checking for mistakes. Okay, so I've got p as a third, and if p is a third, I think we're going to get a third plus a sixth. So what have we got at the end here? Let's have a look at what we've got. We've got, let's write them down all here. S equals 1, Q equals a half, P equals a third, and R equals a sixth. And so I guess when we look at this, yeah, what have we found out? Yeah, how can we relate this to this result here? Because we've found out, we know, let me write it down nice and clear, because sometimes it's nice to have it nice and clear, that from minus 1 up to n, the sum of r squared, minus 1 up to n, the sum of r squared is the quartic with fractional things. It's what was p? A third, a half, a sixth, and 1, I think. A third, a third, a half, a sixth, and 1. And that's a third p cubed. Let me just check that is right. It's annoying when you can't see, yeah, a third p, yeah, sorry, a third n cubed, yeah. I felt like I'd done something wrong there, but I've just found p. Silly. So a third n cubed plus a half n squared plus a sixth n plus 1. Yeah? Now, we found out that. Now, if we go from, how is minus 1 up to n related to 0 to n? Well, clearly, 0 to n is just minus 1 to n, but if you take off a 1, because think about what r equals minus 1 up to r equals n. Think about what that looks like, r squared. You've got minus 1 squared plus 0 squared plus 1 squared plus da 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 da. That's got an extra 1 on it. So if you're going from 0 up to n, well, you need to get rid of that extra 1 in some way, don't you? You need to account for it, that you're only doing 0 squared plus 1 squared plus. So what we can say is this is definitely going to be 1 less in value than that. So if I know this, I can just say, hence, if I'm just going up from 0 up to n, I'm really just going to have the above result minus 1, which is just a third n cubed plus a half n squared plus a sixth n plus nothing. Yeah. Now, can we turn it into the magical answer, which is obviously 6n plus 1, 2n plus 1? Slightly nervous here. Let's have a look. Well, firstly, let's take out a sixth and an n. That's kind of looking nice. Now, I'd have to multiply this by 2n squared. That's looking good. And I'd have to multiply to get a sixth to a half times it by 3n. And to get there, just plus 1. And I mainly did that quick because I know what the answer is supposed to be, because it's a sixth n, n plus 1, 2n plus 1, and that's exactly what that factorises to give. So there's a way you can prove that the sum of r squared is equal to that result. It's a really clever trick, isn't it? You know, that's what I love about doing these questions. They teach you clever tricks. Now, they kind of gave you a big hint of how to do it in the first one. In the second one, that's not really going to work any differently. It's going to be very, very, very similar. In fact, just because I'm a little bit tired tonight, I might leave that one to you and see if you fancy doing it yourselves. You can leave a little message in the comment when you've done it. But really, it's going to work in a really similar way. So yeah, best of luck with that and keep up the good work. Bye-bye.